Right, part 2 of the wiring video. I thought I'd start by showing you the faff I have to go through to charge right now. So, first things first, open up the car. Pop the bonnet. And go into the 12-volt wiring here. Unplug this USB cable, which runs into the cabin. That's my canvas control. Unplug the brake booster. Just take the fuse out for that one. Unplug the power steering start. Unplug the switch gear so that it can't be set into forward or reverse, it stays in neutral. That done. Plug in the charger. Now we can go inside and bring out the USB cable. Yep, that's what it takes. So this is my office window down in the basement cellar. Forgive the very dirty window. Feed out USB extension. Don't get it tangled up in webcam. Out the window. Back outside again. Take said USB extension, and if you can, plug in to takes two hands. Plug in to here. It's tucked away underneath here is an Arduino Duo, I think, running GVRET firmware for Canvas for SavvyCAN. So now that's plugged in. Come back to the car, work out which pocket you put the keys in. Put the keys in the car and find out that your 12-volt battery's find out your 12 battery's completely dead. Fortunately, just enough juice, it sounds like, for the DC to DC converter to kick in. Yeah, can hear the cooling pump running. So now, back indoors. So I'm now back in my workshop. I could take a laptop outside, of course, but Manchester weather, it's wet in the north. It's much better to be sat down here where it's nice and comfortable and I can have my big screen. So I'm going to flip over to a screen recorder now and show you what happens next. So this is SavvyCAN. First thing I'm going to do is connect to the Arduino Duo inside the car over serial. Then I'm going to load a DBC file. This allows me to decode, if you like, the messages coming out of the car so that I can understand what's going on with the charger. These messages then appear in the signal viewer, and I can start to bring up different options and translate those messages, which are blank. Wait a minute. Something's not working here. Forgive the constant clothing changes. I had to stick a jacket on to do a little bit of telly down the line. That's my weird day job. Anyway, what you should have seen there on that screen record is a bunch of messages coming in from the charger and me sending some messages to the charger, telling it to effectively close the connections and start charging at 8 amps. You didn't see that because the 12-volt battery is flat, it turns out. Flat enough that it won't hold the run relay closed, and therefore we can't get into run mode. I think that's what's wrong anyway. I haven't fully diagnosed it yet. But either way, I'm going to have to crack on with this video, and let's get on with the making. So just to recap and clarify a bit, this is the challenge we're trying to solve. How do we turn on cooling and the DC to DC converter in charge mode, but not the other run mode stuff? Because right now we have two modes: on, effectively pre-charge where the inverter, the charger and the BMS are on, and run where we turn on everything else. What we need is a third mode in the middle, where the BMS can trigger a charge mode with the DC to DC converter. This should leave us with 3 relays with a variety of different triggers. On is triggered by the ignition being turned on or by PP detect, something I'll cover in another video. Charge mode, which will be turned on by a relay connected to the battery management system when it detects that the charger is connected and that the system is on. And run mode, when the switchgear is enabled, allowing the car to go forward and reverse, and all the extra bits like power steering and brake booster are also turned on. In order to at least try to make a neat job of all this, I laid it out in CAD using Fusion 360, cloning the main parts like the relays and the fuse box and placing them on a template I took from the existing piece of MDF I have in the old ECU enclosure. So first step is to take that template and cut it out of 6mm MDF. With the template roughly cut out, I can go back to my piece of paper and start to work out where the holes should be in this base so that it can take the pieces that go through, such as the 12-volt terminals and the relay mounts. Now for a quick clean-up, and then I'll have something I can start to experiment with. Next up, we're back into CAD to look at some of the 3D printed parts. For example, this base plate that holds on 3 through-mounted terminals that carry 12 volts, high current 12 volts from the relays into the fuse box. I'm going to take the output of this straight from Fusion 360 into Cura, and from there I can slice it and 3D print it. Octoprint handles the management of the 3D printer, which makes things nice and neat and tidy. and off it goes. With my 3D printed parts, I'm using a variety of metal inserts so that I can use threaded connectors, or rather sort of M4, M5 connectors, rather than wood screws as I used with my original prototype. These are simply inserted just by pushing them over the end of a hot soldering iron and pushing it in, and then very carefully, and with only minor burns, withdrawing the soldering iron and leaving behind the nice threaded connector. Right, so Christmas has got in the way and slowed the production of this video down, pleasant as it was. But I'm back home now and cracking on with the wiring. And following a few repetitions of the video that you saw of me 3D printing things and putting in the threaded inserts, where I've got to is this. This won't be a perfect fit yet. I've still got some tweaking to do of the surround that I cut out. But it's it's part of the way there, but I'll have to take the existing wiring out in order to put this in and test fit it. Let me just walk you through what I've got here. So 6mm MDF for the baseboard. I'd rather get it cut out of plastic or steel or something, but that was proving quite expensive and I'm still experimenting, so I figure 6mm MDF with these reinforcing plates that I'll show you in a second should be fine, as long as I'm not putting sort of threaded screws into it, not putting wood screws into it. And it'll have a good couple of coats of paint and lacquer as well to protect it. So start up at the top here. We've got a 3D printed piece that holds the existing relay holders that I bought. So I bought some cheap Chinese relays, some relay holders. Those are just press fitted, actually super glued in this case, and I didn't quite get the dimensions right for a press fit to be strong enough. So you can see one of the sockets there, and these relays just pull in and out of there, so I can change relays quite easily. This is the top side of the whole thing, so this will be quite accessible. Down here I've got an off-the-shelf fuse array. I have historically been using ones with a single input and multiple outputs, but because I want to be able to vary what's on the on, charge and run relays, I figured I'd go for 12 inputs, 12 outputs, and then I can swap around and vary what's on what circuit. And to power those circuits, what I've got here is 3 terminals. I've stupidly not given myself a screwdriver for this, but underneath these there are metal terminals that go all the way through to the other side, and these take the outputs of the 3 relays into 3 inputs for that fuse board. So I can now run effectively jumper cables from here to any one of these to put them on the charge or the run circuit. Again, 3D printed part, and just with some off-the-shelf M5 for the heavy duty, M4 for the smaller stuff. Threaded metal inserts. On the reverse side here, I've got a single printed terminal, again M5 for the 12 volt supply for these relays, so for the high voltage, or rather the high current supply for these relays. And then actually the control terminals for the relays, the control wires for the relays, I've got a single earth on this side because these will all be switched live rather than switched earth, I think. And then 3 breakouts for the switch sides. So it just all keeps it nice and neat. I can now run my my inputs for these relays to the PP detect, to the on, and to the ignition on, the ignition start. I'll have to run a loop back from here to here, so that once the run relay's on, it stays on. And also might have to do some tweaking in terms of how that's powered. Of course, I want the run relay to only be on when the ignition's on. Otherwise, with that loop back, it'll just stay on if it's running from the unswitched live. So a bit of tweaking to do here to get all that right, but I'll show you that in the final version, I hope.
So from that point there's not a lot for me to do except for remove all the old wiring, and it's a proper mess in there. I'll speed this one up because it took a few minutes to get everything unplugged and out the way. But you can see how much work there is to do in terms of tidying up this wiring.
Right, that'll have to do for this video. It seems to be running on and on, this bit of the project. So we've got to the point where the old electrics are out, the new electrics are at least templated, and I've got a board that needs some fettling. I've 3D printed all the parts, I think. I may have to print some new ones or make some tweaks. In the next video I'll sort out that rat's nest of wires. I'll test fit the new sort of electrics board, and then trim that and paint it and do final assembly on that, and with a bit of luck get it in, all I'm hoping in the next couple of days, because I really don't want to be out without the car for that long. 3D printers going in the background for a future video, one about installing the heater controls and modifying the interior. So if you like this stuff, whether it's about Z3s or electric cars or generally just daft projects, please do like and subscribe. Thanks a lot for watching.